The next one is module. How you can or why, how you can use a module, and or why you can use a module and when you can use a module. Say for example, this is a set of statement in your program, a long list of statements. Now at the next time after 1 year, if you want to check this statement, and if I ask you to modify this program or any of these statement after checking, then it will be very difficult for a long list of statement in a program to change or to modify the program. So instead of that, if you create a group with some set of statement, and then those group can be represented as a group, and then if I ask you to change a particular operation, and if you go to that particular group and check whether which statement you have to modify, then that will be little bit more easier. That is called, that grouping of statement is called modularization. So that is one advantage. I will explain you more advantage of this modularization procedure. So writing program as a long as one long series of steps, not a good practice. So instead of that, you break down into groups and of smaller tasks. Each of these group will be used for a particular task or a particular small unit of work. That's why if I ask you to do or change a particular operation, a particular unit of operation, then you go for that particular piece of code and then change it instead of looking at whole program from top to bottom. So these smaller units are identified or will be named as with different word or different keywords like module, subroutine, procedure, function, method, whatever it is. It the meaning is same. Like Visual Basic uses procedure or sub procedure, C++ uses function, C hash, Java and other object oriented languages uses method. Programming like COBOL, basics are used the subroutine name. So whatever it is, the concept is same. Or grouping the statements, a list of statements based on the task. So the process of breaking down a large program into module is called modularization or functional decomposition. Okay, decomposing a program, a long list of program based on the function. So that's why it's called functional decomposition or modularization. It is breaking down a long program. Three reasons to modularize a large program: provide abstraction, helps multiple programmer to work on a problem. So like for example, if a problem can be divided into different groups, and if I have 5 students to solve that particular problem, then I can ask each of that student to solve a particular problem, and they will solve that particular problem and provide me the solution, and I will combine them in a parent program where all these group of solution will be incorporated and will be created a final solution for the problem. So that's why multiple group of programmer can work on the same problem simultaneously, allow you to reuse work more easily. So like for example, if I ask you to write every day's routine, and say the most of the work same, so instead of writing all the steps every day, what you can do, you can write those set of steps which you perform most of the days, you group them together and just give a point that I performed something written in page 5, and then tomorrow you instead of writing the same statement, you just write I performed a group of tasks written in page 5. So instead of writing the same thing again and again, you can reuse whatever you have written earlier. That will help you or the programmer to write a solution for a particular problem by using any programming language. Like a variable, for a module also you can declare, define and call. Declaring means write a name of that module with the type of the module, and defining means what operation this module will perform. That exact set of statement will be the definition of that module. And calling a module means from a program you want to call a particular subprogram or a group of module, then you have to call those previously written modules in your current module by using some procedure, and that procedure is called calling a module. Like for example, assigning a value to a variable, you call it assignment operator, right? So similarly, for calling a module from one module to another module, that's called calling a module. And to create a module, you must have a header. Header includes the module identifier and possibly other necessary identifying information like types of the variable, it accepts type of the variable, it returns, depending on the programming language. Actually, this header depends. Okay, naming a module is similar to naming a variable. If you want to write the first name of a person, then the variable name will be first name. If you want to write a module for cooking rice, so the module name will be such that by looking at the name, you can say that this module actually explains the steps for cooking rice. And the body is actually consist of set of steps which are used to solve the problem for which this module has been created. And the return statement, usually the last statement, but sometimes if you want to stop the execution at some point of time and want to return back based on some condition, then this return statement can be at some point in the middle of the module also. Anywhere if you find this, or if you want to write this return statement, that means from this return statement, program will identify that you have to finish the execution there and you have to return back to the parent module from where child module has been called. Okay, identify the point at which the control returns to the program or module that call the module from where this module actually called. You have to return back your control. In nowadays, in most of the programming languages, the most advanced programming languages, this you don't need the return statement. Okay, sometimes if you don't include this return statement, automatically after finishing the execution, it will return back to the calling program. For example, this is a set of statement, say like declaration, string name, number, balance. So two variable has been declared. One is string type, another one is num type. String type variable name is name, num type variable name is balance. So you collect the value of name and balance from the user. You want to display the output that ABC manufacturing, output 47 Park Lane, output Omro WI 54963, output customer name. So this is the address of the customer and the total balance of that particular customer. So this is a set of statement you want to execute. Now, if you want to write this set of statement in a pseudocode, then it looks like this. So this is the flowchart. This is the pseudocode of this corresponding flowchart. Now, for module, as per the modularization, what you can do, instead of all these statement 1, 2, 3, 4 or 5 maybe, where instead of displaying one by one, what you can do, you can write a module that display address information, and then you write all this address information in a box. You write the module name, and then you write the return statement at the end, and in between you just group them together, whatever the steps you have written in the last flowchart, and then use this symbol. And the name of this function, this module, is called display address information. So this is a particular flowchart where you can call this display address info, and again after executing all this, you can return back here. Now, if you want to write another program where this same piece of code you want to write, then you just write the beginning and end of that particular program, and after that, wherever you need this piece of code, you can directly write this box. Okay, instead of writing these statements multiple times, you can just write this box, and somewhere in this document you have to represent what the meaning of this box is by using this set of diagram. Similarly, for pseudocode is like this: display address information in first bracket, and return, it will display all this information, and after executing one by one. So first it will execute this line, this line, this line, and this line. After that, it will execute, it will come here, and it will immediately return to this, immediately go to this place, and it will execute this line, and this line, and again return back here and execute this line and this line. Now, a main program executes a module by calling it. To call a module, use its name to invoke the module, like the last example. To call a module, you need to use the name of the module. Okay, name of the module is this, and to call this module you have to use the name of the module. This is the very general syntax. For a program specific syntax, every program has different syntax for calling, for displaying, for declaring, for defining. Each of these operation, every individual program has their own syntax, and if you want to write a module for a particular program, you have to follow the syntax of that particular program. Whatever I am explaining here is a general concept of modularization. Say for example, if you have multiple modules in a program calling simultaneously one by one, or one module within another module in a nested manner, like A is calling B and B is calling C and C is calling D, and then you have to execute one by one. After at some point of A, you have to stop there and you have to call and you have to execute B, and at some point of B you have to execute like for example this way. Say there is a program A consisting of some statement, okay, and at some point of statement you want to call B, and B is somewhere here where you have set of statement, and at some point of B you call C. So in B, say you call C from B and you call B from A. So by using this parenthesis you can limit these boxes. Okay, so you have a program or you have a function like this. So you have a program A, from there you a module A, from there you call a module B, and module B is written here, and from module B you need module C. So module C is somewhere else. So this is called nested calling. In this kind of situation, how the program compiler will understand who is calling whom, and after that where to return. After finishing C, you have to return back to B and then execute this set of statement, and after finishing this set of statement, return back to A and then finish this set of statement and return back from A. So this kind of information is written in a stack, okay, in memory address in the stack, where the computer keeps track of the correct memory address in the stack to return after executing a module. Where to return, after whom, that kind of information is actually stored in a stack. And variables in a module, if you have a module A and if you declare some variable X inside that module, then the X can be used only within that module A. So here this, if you have a module, then the local variable and the global variable concept actually works. Where this variable can work is actually the scope of that variable. Like variable and constants are local to the module in which they are declared. Global variable and constant can be accessed from anywhere in the program and can be accessed by multiple modules present in that particular program. Local variable is declared inside a module. It cannot be accessed by the statement that are outside the module. Different module can have same local variable names. Like for example, if you look at the example here, in function A, you can write num l name. You can write a variable name num l name, and also you can write in B, you can also write a variable name l name, because this l name has a scope within this B, and this l name has a scope within this A. So if you pass this variable name here to this B, then that is called message passing or argument passing arguments. So an argument is any piece of data that is passed to a module when the module is called. Okay, that name can be same, can be different, that does not matter, and that sometimes create problem depending on the language you are using. A parameter is a variable that receives an argument that is passed into the module. Okay, it's like this. That value is a parameter name which is passed to that module double number, where a piece of code is written like this, where value module will accept will be doubled by multiplying 2 and will be returned from the module, or will be displayed from the module. Okay, like this way. You have variable names here in the module. They are local to that module here. You cannot access the module name from there to this place. This line 1, line 2, line 3 cannot be accessed here. In case of pseudocode, you can write something like the same kind of variable declaration within a particular method, like this way, which you cannot access from this parent method, but they can be displayed from the current method, display address information.